Right, it is 9 o'clock, so I'm going to get started. But before I get started with class material, I'm going to do something that is completely non-related to programming. It has to do with smoking, okay? Smoking on campus and smoking in general. I don't know how many people smoke, in this class, outside of the classroom, obviously. But I just have, something to talk about because I do want people to understand, the effects of smoking. And before that, I'm going to point out something that is actually slightly related to this class because I helped make this possible. So let me show you what I mean by that. This is a smoking machine, and yes, it is an actual smoking machine. And guess what it's for? It's for smoking, right? Using a machine to do all the smoking. When you look at this picture here, this photograph, this is the actual smoking machine, and these are called exposure chambers. And the exposure chambers typically would have lab rats or some other animals keep inside, so they would be exposed to cigarette smoke. This is the actual smoking machine. This is the magazine, kind of like a machine gun, magazine, except this one is gravity fed and not spring loaded. So the cigarettes will kind of come down into here, and there's a plunger here. I know the picture's kind of fuzzy. There's a little plunger here that will insert the cigarette into a carousel, and then the carousel will rotate so it can light up the cigarette, and also there's a puffer, basically just an air pump to puff, to inhale the smoke, and then the inhaled smoke will go through the tubing and get into the animal exposure chamber, and then it will go through like a whole bunch of carbon filter before it exits out of the whole machine. Okay. I do not make the whole thing. I just make the controller and also the software that goes along with it. So from that perspective, it is related to this class because guess what programming language I use to program that controller? Regular C, which is a subset of C++. Okay. So from that perspective, it is related to this class. So why do you think companies, pharmaceutical companies for the most part, purchase these machines? It's not the cigarette manufacturers that purchase these machines, it's the pharmaceutical companies. Well, exactly, they have to do some research on the effectiveness of their medicines, right, or the drugs. And so what they do is they use these machines to induce respiratory system illness on animals so that they can then test the effectiveness of their drugs. And they found, after years of research, cigarette smoke is the most effective way to artificially induce respiratory system diseases. There's no cheaper or more effective way to do it. Okay? So I'm not saying, don't smoke or go ahead and smoke. I'm just telling you what I know about smoking because of this project that I participate in. And these machines are selling like hotcakes. Now, it's a single guy, it's a one-person operation, and he has to make like 15 or 20 of these machines every year and sell these machines all over the places. So he has to go to Europe, Asia, and all over in Northern America. And that's because pharmaceutical companies all over the world use these machines to test the effectiveness of their, drugs. And I think, it really kind of tells people, what kind of an effect, smoking has, at least on the test animals. We are talking about test, lab rats and, animals like that. But I think on people, it probably has similar effects, okay? And people live longer too, so that means, there's a longer period of time to, accumulate the effects as well. Two more things to talk about, and these are strictly my personal opinions. One is sometimes it's not the person who is smoking who is basically saying, okay, but who are you to tell me not to smoke at a no smoking zone? Who's talking? The cigarette, because of the addiction. Now, I know that part because my father used to smoke. When I was little, my father used to smoke, and occasionally, he would drop the hot ashes onto me. Not intentionally or anything like that, but it does happen occasionally. Um, and when he tried to quit smoking, it was hard. Okay, he was really, really trying very hard to quit smoking. He did successfully, but I could definitely tell that it was not easy. So a part of it is really the cigarette talking is like, oh, don't quit. You got to keep this going. And then the second thing is, if you just kind of imagine there's a time machine or a way to kind of look into the future, or from the future look into the past. I think people who currently smoke, their future selves going through the portal or going through the lens, looking into the past, will be screaming and say, "Why are you doing this to me? Wait, that was actually me." So I think it's just a matter of perspective, and that's it. That's my spiel about this whole topic. And just to let you know, because some of you are transferring to a 4-year university, a lot of campuses are now a non-smoking campus. They don't have designated smoking area. It's like non-smoking. Unless you get behind one of these machines, then it's probably okay. All right, so that's it. I hope I'm not being too preachy, but am I getting too preachy a little bit? Yeah. All right, so I'm going from one preachy to another preachy, which has to do with your homework assignment. So I'm hoping most of you, if not all, I'm hoping everybody can get it done and get it done right. So we'll take a look at the homework assignment and just talk about the solution, but not so much the solution itself, which is a one-liner, but how do you get to the solution? Okay, how do you figure out, okay, how do we write a program like this? Okay, so what I'll do is I'm going to, I think somebody told me that this actually works, copy and paste. It won't work in QEMU, but it does work when you have a dumb terminal like PuTTY. You can actually copy and paste. So I'll go ahead and paste into a program called findmax2.c, or main.cpp is fine. And then select edit, paste, and wow, it does work. Okay. So the first thing I'm going to do is just to do a G++, compile this, and make sure that it does not have any syntax errors to begin with. It's going to give me a warning, and I'll show you what the warning is and why the warning does make sense. Okay. And find, what's the name again? Main.cpp. Go. Okay, so it does give me a warning, and the second warning, we have seen this many, many times already, so it's no big deal. The first warning, on the other hand, is something that we don't see all the time. It's complaining on line 4, and it says no return statement in function returning non-void. So let me explain what this is, because this is actually quite important. It's basically complaining that findmax2 as a function is declared that it has a return type of int32_t. In other words, it is supposed to return a 32-bit integer, but the subroutine or the function is currently empty. There's nothing in it, and as a result, there's no return statement. If there's no return statement, what is happening on line 9? Because line 9 is using the return value of findmax and store that into x. So what exactly is it going to store into x when I do not specify a return value for this function?
Garbage.
It's some kind of garbage. Okay, this program is going to run and it will come back with a value, but it is something that we don't know what it is. Okay. So that's why the compiler is complaining and say, hey, this does not seem right. Okay, it just doesn't seem right. You have to specify a return statement. And I just want to kind of re-emphasize there's no drinking policy in this class. So please keep all the drinks in capped and not drink during class. All right, so let's go ahead and look at this program and figure out what we can do about this to get it to work. So your job is to specify the body of the function findmax2 so that it returns the maximum of the two parameters for the two variables, x and y here. That's your job. Okay. So now the question is, how do we find the maximum of two values? What do you think? Go ahead.
I don't know. I used a ternary
That makes perfect sense to me because the ternary operator is the only thing that can quote unquote make a decision based on the condition. Okay? Because when you have two parameters, one can be larger than the other one, or it can be the other way around. So we cannot just say, oh, I want to return x or I want to return y, because it depends on which one is actually greater. And the ternary operator is the only thing that can give you the ability to make a decision and say, sometimes I want x and sometimes I want y. Okay, so let's go ahead and take a look at the ternary operator. And this is a typical way for me to write any expression. And I will just write out the structure of the expression first, and then we'll go back and fill in the contents. So in this case, because we are finding the maximum of x and y, so that means sometimes x is the larger one, and sometimes y is the larger one. X is now what we call the then value, or the true value, and y is called the else value, or the false value. So the true, false, or the then, else is actually corresponding to a condition that we have to specify as the first part of the ternary operator, which is this part here. This is going to be an expression, and if it is true, we specify this is the value that we evaluate and return, and if the expression is false, this is going to be something that we return. So it becomes, this seems to make sense, x is greater than y is the condition that we want to specify here, because when x is in fact greater than y, we just want to evaluate x as an expression and use that value as the return value of the function. If x is greater than y is false, which means x can be equal to y in that case, but it's still okay to use y as the return value, because x and y, if x and y are the same, then they are both the maximum, and it's okay to pick either one to return. And that's the answer. That is it. Okay. So are there any questions about this particular homework assignment? About the process to do it, about the operator that you have to use, or about any concept that is involved in doing this homework assignment? Or about how this is a little bit related to the absolute value example that I went through in class. Yeah. Yep.
I was struggling for some reason when I would go back and test like my input, it wasn't coming out right. So I added an additional variable z, so that when z equaled greater than x or y, maybe I have to show you too, but I just wasn't sure if like adding in that additional variable.
Did you do it in main?
I did it in main. Yeah.
Okay, it's probably okay, even though I said do not modify main. As long as the number of parameters to find max to is the same, my script will still work okay. Yep. All right, well, now that we have a suspected solution to this particular question, I cannot just show you this code and say, yeah, that's going to work. I'm going to have to test it, right, to show you that it does work. And you should do the same thing with your own homework submission and test the program before you turn it in. Okay, so let's go ahead and actually test it. And we have to recompile because I just changed it. And that will get rid of the first error because now we have a return statement in find max 2. And then we can use G++-O to link the program. And now it's time to run the program. It doesn't really help when you run the program all by itself because it doesn't do any printing, it does not have any input. So the only sensible way to test the program is to use GDB. When you use GDB, you can list the program. Oops. Let's see.
When you link
okay, -O. Sometimes I make that mistake too. Okay, so now when we list the program, we can put a breakpoint on line 10. There's actually another way to do this. You can put a breakpoint in main like that too. Okay, that will actually work. Basically, when you say break at main, it means break as soon as we get into the main subroutine. That's the same thing as breaking on line 10. So now we can run the program, and when we get to this point, the program has paused. And I'm not even interested in find max 2 using 1 and 2 as parameters as arguments in this case. I can now use the print statement and call find max 2 with any parameters that I want to. In other words, now I'm free to say, oh, let's find the maximum of 32 and 16. Okay, that works out okay. So let's reverse these two, 16 and 32. That works out okay as well. What about 32 and 32? That also works out. Now, if you have 5 max 2, you can now say, what about this one? Can we do something like this? And you can. So you can actually stack up all the function calls and use the result of one function call as the argument of another function. And you can stack this up any way you want. There's no limitation. And this is the way you test the program. I don't even have to run the rest of the program, and now I have evidence that this program does work correctly. Any questions about this? No questions? This is all okay? All right. So it's not really just the solution that matters. I also want to show you guys how to test your program in GDB, because if this is how my script is going to test your program to make sure that it does work correctly, is to go through GDB to test it. Okay. Any other questions? Go ahead.
Are you recording?
I should be recording. Let me double check. Yep, I am recording here, and it is inputting from the audio channel correctly. So, thanks for reminding. All right. Any other questions? Okay, no, if there are no questions, we'll move on to the practice questions for the first exam. The actual exam is 1 week from today, so that will be next Thursday. So you definitely want to make sure that you will be here next Thursday on time. Next Thursday. Wednesday, sorry, Wednesday. 1 week from today, Wednesday. Next Wednesday. All right. All right, so let's go ahead and take a look at those questions. And these are practice questions, which means it is by no means the actual test may not have the same number of questions, nor the same how should I put it, level of difficulty as these questions, but it will be the same type of format. Okay, same type of format. So we'll go ahead and take a look at these questions and figure out the answers together. Question number 1, what are the values of variable x and y after the following expression statement executes? This is called an expression statement because it is really an expression like this, but since I have a semicolon next to it, it becomes a statement. Okay? Assume x and y are both of type int32_t. Okay, so they're both integers. What do you think is the result of evaluating this expression? Well, let's do it step by step, okay? Because when you look at something that is kind of long and complicated, the best thing to do is to break it down and figure out what are we supposed to do first, and then what is the next one, and what is the next one. The first operation is this particular assignment operation here. And yes, this is actually an expression, okay? It has a value that it has a value. The expression itself has a value, which is 5 in this case. But more importantly, the side effect of this expression is x is changed to have a value of 5. Now, when you have a comma-separated expression, it is guaranteed to evaluate from left to right. So you're guaranteed the ordering of those expressions. So this one has to evaluate first, which means x is 5 after this. And then you go to the next statement in the comma-separated list. So this means by this time x is already 5. 5 plus 5 is 10. The value of this expression is 10, but the value of a comma-separated expression is the value of the last expression, or the rightmost expression, which this one is. So that means 10 is also the value of the comma-separated expression, which is this entire part here. If that is 10, 10 plus 5 is 15, so that means y should have a value of 15, and x should have a value of just 5. Okay. So are there any questions about number 1?
Is there an answer key to the practice exam?
No, there's no key, but you can always enter these into a program, compile and run it, and then use GDB to verify it. Which by itself is actually a good exercise. So I'll do it for this one, and you guys can do it for the rest. Actually, I'll do it for every single one just to make sure that I'm not spewing wrong answers in class, which I occasionally do. So this is q1.cpp, and we'll just go ahead and do a count, include stdint.h, because without that, we cannot refer to the integer types. So we got x and y here, and then I'll just type the entire expression the way it is. X equals 5, comma, x plus 5, plus 5, return 0, g plus plus dash g dash c q1.cpp, g plus plus dash o q1 q1.o gdb 1. Put a breakpoint on line 7, run the program, single step, print x, print y. So there's your key. Any other questions? Now, having a program already done like this gives you some options of, hey, what if I tweak this program and it becomes this instead? What's going to happen? Okay. In other words, I'm not just giving you a single question, I'm giving you a template so that you guys can play with this to give yourself more variations of the same question. So I'll kind of give you guys an idea of what I mean by that. Okay. So what if I put a plus on this side here? No, that won't work because the x does not have a value yet. The compiler would actually complain in that case. What if I put an equal symbol between the plus and the 5 here? Then x ends up with a value of 10. Would it change the value of y? The answer is nope, it's not going to change the value of y because x plus equal to 5 will still give you a value of 10 as an expression, and it will also at the same time change x to 10. Okay? So those are the things that you need to do to kind of play with the code and figure out what it's going to do. Any other questions? No other questions? You can also mess around with these operators. Instead of a plus, change it to a bitwise OR and find out what it's going to do. Change this to a bitwise AND and find out what it's going to do. Okay? So, but every time you change it to create a variation of this question, don't run it in GDB to figure out what it's going to do. Figure it out in your head first, okay? In your mind, figure out, okay, I think this program is going to do blah, 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 and then use GDB as a verification method, okay? But that means, you have basically, it's limited only by your imagination of, how many variations you can create out of the questions that I have already given you. Is that okay? So that's basically one way to study for this class, is really looking at the questions that are already here and say, okay, but I want to make this more complicated. And then you can see the result of making it more complicated. All right. Let's move on to number 2. Okay, so here's question number 2. Question 1 to 4, I think, have pretty much the same format, except they test you on different type of operators. So this one asks about the same thing, except x has an initial value of 45 and y has an initial value of 72. So I want to figure out what this is going to do. So the first reaction of most people is to say, holy smokes, look at this long expression. I have no idea what it is going to do with all the gibberish, right? Okay, so don't panic, okay? What you need to do is to figure out the ordering of the operation. Okay, what operators are really involved here and how are they related to each other structurally speaking? Okay, it does not hurt if you want to draw a picture of how these operators are related. So the first thing you want to do is to use the parentheses as an indicator and figure out how these things are actually grouped. Look at this open paren here. Where is the close of this parenthesis? It's all the way over here. Look at this parenthesis here. It ends all the way over here. And this one obviously is just that, okay? So that means at the top level, this is a ternary operator, okay? Now that you know it's a ternary operator, what you can do is on a piece of paper, you just say that, oh, okay, we have a ternary operator here. But once you know it's a ternary operator, you know it has 3 components. So now you can try to figure out what are the 3 components. Okay, so we have 3 components here. The easy one, okay, goes first, not a problem. And then the second one, is a comma separated expression, right? The second one is y/equals 9 and x/9/9. So this one is basically a comma-separated expression, which has two parts in this particular case. So you look at those two parts, and depending on how comfortable you are with the operators that are here already, you can, if you feel comfortable enough, you can just say x slash equals 9 and x slash 9 here. Okay, that's fine. Okay, but what I'm doing here is looking at the expression in a structural way, just to figure out what are the parts of the overall expression and what is involved in each individual part. The first one has the ampersand, or the logical and, as the last operator. In other words, if you just look at this part here, the logical and is the last thing that you do. So what are on the two sides of the ampersand? Okay. We have the negation of x mod 9, and then we have the negation of y mod 9. Okay. So that's how you break down something that looks really nasty like that into smaller components, so that you can figure out, okay, so what do we have to do first? Well, obviously you have to do the lowest level expressions first. So this is something that you have to evaluate first, as well as this one, so that we can figure out whether the condition is true or not. Knowing whether the condition is true or not, then you can either pick the middle one, which is the then value, or the yes value, or the true value, or the else value, or the false value. Is that okay so far? Okay. All right. Now we look at this expression. Okay. We look at the expression not x percent 9 and ask, okay, but what is it really saying? Okay, it doesn't seem to make any sense to me, because the percent symbol is a mod operation. It gives us a numerical value. The exclamation point is a logical operator. Okay, it's negation. It doesn't seem to make any sense at all. But let's see what it is actually going to do. Okay, so what I'll do is I'm going to use mousepad here to kind of replace the whiteboard. Okay. And we'll just take a look at exclamation point x mod 9 to figure out what it's going to do. Okay, so I'm not worrying about the negation at this point, because the first thing we have to do is to figure out what is x mod 9. Okay, x mod 9 is what? It's based on division, but it's not taking the quotient. What is it? It's the remainder of the division. Okay, and x has a value of 45. 45 divided by 9 has a remainder of 0. Okay. So this part is actually just 0. Fine. Okay. Can we say what is the negation of 0? Non-zero. Exactly. Okay. The negation of 0 is non-zero, because it is just anything but 0. Okay. But that's fine. Okay. We just know that this is non-zero. So the same thing applies to the other side of the conjunction, which is y percent 9, which is y mod 9. Y starts with a value of 72. 72 divided by 9 has a remainder of 0 as well. Okay, so we say y mod 9 is also 0, and not 0 is non-zero. Okay, we don't know exactly which non-value 0 value we are dealing with here. We just know it's non-zero. So now we can get back to the ampersand, because now the ampersand is now saying we have a non-zero value on the left-hand side, we have a non-zero value on the right-hand side, and the result of this logical AND is going to be what? Non-zero. Okay, that's the only conclusion, is not zero. Okay. So what happens when the first expression of a ternary operator is non-zero? Which value do we pick as the value of the entire ternary operator? The first one, the true value, right? So the true value by itself is kind of complicated too, because it is a comma-separated expression. So we have to now evaluate the comma-separated expression, which is this part here, and figure out what this is going to do. So I'm going to copy and paste it into Notepad here, or mousepad, and try to figure it out. With any comma-separated expression, it is always evaluated from left to right. In this case, it doesn't. Well, it does matter which way, but because, well, I'll tell you why it's a little bit later. Okay, so we have to evaluate from left to right. Y divide equals to 9 is a compound assignment statement, and it has two effects in this case. The first effect is what we call a side effect. It is going to change the value of a variable. The second one is just the value of the expression itself. Okay. Can someone tell me another way to write y/equal 9?
Y equals y divided by 9.
Y equals y divided by 9. Exactly, it's the same thing. It's a compound assignment operator. Okay. Well, now that we know that it really is the same thing as this, and y has a value of 72, what do you think is going to be both the value in y and also the value of the expression? 8, right? Okay. Now I'm hoping that no one really needs a calculator for this type of calculation, but I will bring a whole bunch of Dollar Tree calculators, just in case anyone says, but I feel more comfortable with a calculator, and there will be on-loan calculators available during the test. And yes, they are actually Dollar Tree calculators. They're $1 each, but it's not really that good of a deal because at the beginning of each school year, you can actually buy a scientific calculator for $1 at the Dollar Tree.
What?
Yes.
What?
Yes.
I didn't even know this.
You pay $1 and you buy a scientific calculator with sine, cosine, log, exponent, and all kind of cool stuff like that. I don't think it can do hexadecimal numbers or binary numbers, so it may not be 100% really useful for computer science people, but for others, is that a Dollar Tree? If not for anything else, you keep one in the backpack just in case your TI is not functional or stolen or for whatever reason you cannot use it. It's a backup, right? If the $1 one gets stolen, it's like, eh. Okay, so the effect of the first expression, y/equal to 9, is y becomes 8 because it is the quotient of the division, and then the expression is also evaluate to a value of 8, which we toss away because there's another expression in the comma separated expression here, so the value of the first expression is not even relevant, but it does have a side effect that is useful. The second expression is x divided by 9. X actually has a value it has a value of 45. 45 divided by 9 is 5. Okay, and that becomes the value of the comma separated expression. All right, so 5 is the value of the comma separated expression, which is this one here, but this is the true value, which turns out to be the value of the entire ternary operator. So that's why x is going to end up with a value of 5 here, and y is going to end up with a value of 8 as a result. Are there any questions about this? Any questions? No? Okay, well, we can go ahead and test this one too. So we'll go ahead and test this particular program. I'll just copy Q1 to Q2, and then we'll edit Q2 to test this code. So in this case, x has to be initialized to 45, y has to be initialized to 72, and then we'll just go ahead and type the entire expression here. And since I'm lazy, I'm going to do this. Like so. And then we'll g++ dash g dash c. Q2.0. And this time we do have to, well, I'm going to just put a breakpoint on line 10, run the whole program, print out the value of x, which is correct. It's the same as what we thought it should be, and y also has the value that we thought it should be. So this is how we, kind of quote unquote study for the test. Okay. So now what can you do to kind of play with this program? Okay. It's up to your imagination, right? But basically what's happening here is we are figuring out whether they are divisible by 9 or not. If they are, in fact, divisible by 9, then we get the other factor of these numbers. All right. right, that's number 2, and number 3 is over here, and number 3 focuses more on bitwise operations. So we have a bitwise AND here, another bitwise AND, and also a bit shift operator. This is a left shift operator here. All right, and I have the same assumptions. X initially has a value of 45, and Y has an initial value of 72. So we want to figure out what is the the end result in X and Y. That's the question. So it's the same thing. We want to figure out, okay, exactly what are we doing here, and we have to evaluate each sub-expression by itself first, and then we will combine the sub-expressions to figure out what is the actual result of this operation. So I'm going to erase the whiteboard, and well, I think I can do this in mousepad in a really step-by-step way. Let me give it a try. So when you're working on these questions or working on a variation of these questions, do not just change the question or the statement itself or the expression itself and just run it through GDB. You want to figure out what it should be first, and then you run it through GDB to verify that your understanding is correct. Okay. So we'll go ahead and take a look at this one here. We'll focus on X bitwise AND 15 first. Okay. Whenever you're dealing with bitwise operations, it's really helpful to look at numbers as binary numbers. Okay, and so in this case, it's really helpful to convert the value of X into binary as well as 15 into binary. 45, which is the value of X, okay, is if you express it in base 2, it's 32 plus 8 plus 4 plus 1. Okay. So what we are leaving out is a 2 and a 16. Okay? So there's no 2, so I can say 0 times 2 if I want to, and there are no 16s here. 0 times 16. And the reason why I spell out the missing ones is so that I know which bits are zeros and which bits are 1. So once we know, as a basically a multiplier of powers of 2. Then this is a 1, this is a 0, this is a 1, 1, 0, and a 1, and a 1 here. So we have 1, 1, oops, we have 0, 2, okay, never mind, okay. I misread, okay. So we have 1, 1, 1, 4, that makes 5, and then we have 1, 8, that makes 13. 13 plus 32 is 45. So I just want to double check, yep.
So it says assume that they're both 32-bit integers. Does that not matter for the purpose of questions like this? Like, should you write out all 32 bits, or does it not?
When you have a bitwise NOT or a exclusive OR, then it does matter because you're potentially turning the implied zeros into ones in that case. But when you're dealing with bitwise AND, it's okay not to write out all the extra zeros. The bit shift operator is basically the same way, because you're not doing anything with the implied zeros. But when you're dealing with exclusive OR, which is the caret symbol, or the bitwise NOT, which is the tilde symbol, then yes, it becomes important to know the actual width of the integers. That's a good question. Okay, so now we know 45 is 1, 0, 1, 1, 0, 1 in base 2. Okay. The next question is, what is 15? 15 is an easy one because it is 1 less than a power of 2. That makes it very easy. 16 is 2 to the power of 4. That makes 15 1, 1, 1, 1, just 4 ones. Okay. So this is 1, 1, 1, 1, 1, 1, 1, 1 in base 2. So when you look at 1, 0, 1, 0, 1, 1, 0, 1, bitwise AND, right here, 1, 1, 1, 1, then you are preserving, the lowest 4 bits, whichever. If it's a 1 to begin with, it becomes a 1. If it's a 0 to begin with, it is a 0. So I'll just go ahead and do the whole thing here. 1 and 1 is a 1. 0 and 1 is a 0. 1 and 1 is a 1. And 1 and 1 is a 1. 0 and 0 is a 0. 1 and 0 is a 0. So that's the result. of the first operation, or the result of x ampersand 15 is this number in base 2. Now that number in base 2 is basically 1 plus no 2, there's a 4, and there's an 8. So that is basically 13 in base 10. But we don't want to even look at it as 13 just yet, because we have a bitwise OR operation here. Okay? So now it's time to look at the left-hand side, or excuse me, the right-hand side of the operation. Y ampersand equal to is also a compound assignment operator. In other words, this is the same thing as y equals to y ampersand blah blah blah. Okay, it's just another way to write out the expression. But nonetheless, we have to figure out what is this part here, and also what is the result of the ampersand. Okay, so we'll go ahead and figure out this part first. Okay, 15 left shifted 4 times. That's basically what it is. Okay, so we have to figure out what is 15, but we got that one already. It's 1, 1, 1, 1 in base 2, and we want to shift it to the left-hand side by 4 times. That means it ends up as 1, 1, 1, 1 with 4 zeros as the least significant bits as a result. That's the left shift operator. You shift out whatever is on the left-hand side, and then you shift in zeros to pad whatever is on the right-hand side. Okay, so we know this expression now, and we just need to do a bitwise AND with y. So now you have to figure out what is y as a base 2 number. Y is 72. Okay, so if you look at 72, you have to re-express it as a base 2 number. This one is really easy because it is 64 plus 8. Okay, and 64 is 1 followed by 6 zeros in base 2, and then 8 is 1 followed by 3 zeros in base 2. The number of zeros in binary form has to do with the power of 2. And because 64 is 2 to the power of 6, that's why it is written as 1 followed by 6 zeros in base 2. So that's why I can get to these pretty quickly. So when you add up these two numbers, it becomes 1001000 in base 2. So now what is left to do is to do the bitwise AND operation. So we are taking this number in base 2, and then we are taking the bitwise AND with 11110000 in base 2, and this is not too hard. Okay. Now, when this is a missing spot here, it is implicitly a 0. So you can always pad zeros on the left-hand side, when you need to. And the end result is this is a 0, this is a 1, 0, 0, 0, 0, 0, 0, base 2. Okay. And this is the actual value that will be stored in y. The reason why this is going to be stored in y is because this is a compound assignment, which means we first perform the bitwise AND, and then we store the result into y. So y eventually becomes 1 followed by 6 zeros in binary. What exactly is that value in base 10? It's 64. So we know that y is going to be 64. Okay. But what is x? What about x? Okay. So when you try to figure out what x is going to be, you have to look at the value on the left-hand side, which is 00001101 in base 2. That's the expression on the left-hand side. And then we do a bitwise OR with 01000000, which is also in base 2. When you're doing a bitwise OR, if you see a 1 in a column, it becomes a 1. If you see no 1s in a column, it is just a 0. So it becomes 01001101 in base 2. That's the value that we are storing in x. And that turns out to be what value? Well, you can always figure it out by adding the individual components. So we have 164, we don't have 32s, we don't have any 16s. We got 18, 14, 02s, and 11. So if you add up these numbers, 77, I think. Yeah. So 77 is the value in x. So it is a lot of individual operations, but it all has to do with bitwise operations here. So you have to be able to convert a number into base 2 first, and then perform all the operations, and then convert it back into base 10. Yep.
So we get to use a note sheet on the test, is that right? Or?
Absolutely. It's an open book, open notes type of exam. If you have any textbook that you find that is really useful, bring it along. You can print out all the notes that I have gone over in class. Take it along with you if you think it's useful. If you take your own notes, definitely bring it along too. You can even make a quick reference sheet for the exam itself, so that when you study, you just identify all the key components that you think are really important, so you can look up those things really quickly and not having to flip through all the notes in order to find something. So anything that is either printed or handwritten ahead of time prior to the test, you can bring it along. Question?
So the X is 77 and Y is 30.
X is 77 and Y is 64. Y is 64 because of this one here. But the answer is something that you can figure out, if you just type this as an expression into the program template that we have. In fact, I'm just going to do that just in case I make a mistake somewhere. I hate to make a mistake and not know about it. Note what I just said. I hate making a mistake and not know about it. I do not hate making a mistake. It's just not knowing about it. That part bothers me. Because making mistakes is a way to learn, if you know what it is. All right, so let's go ahead and remove this line and replace it with this line here. And then we'll do a G++-G-C-Q3.cpp -O Q3 Put a breakpoint on line 10. I'm just going to run the whole thing through. Print X, it is 77. Print Y, it should be 64. Okay.
So while we're doing the test, like we could technically write this program and then just get an answer like that?
Well, that's why it's a paper test and you cannot use a computer. Yeah, if you want it to be a program test, like where you can actually use G++ and GDB and stuff like that, the format of the test is going to be different. I'll be asking you to write a subroutine to do da 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 da, and you are going to have to synthesize and actually put a subroutine together to do it. I don't think we are ready for that. Trust me on this one, okay? For many semesters in different classes, and these are 400 level classes, and I thought, they can do it. So the question in the test is not even to make a new program from scratch to do blah blah blah. It is a homework assignment that my students have been working on for weeks, okay? Because it's a multi-step homework assignment. So the first homework assignment is the basis, and then the second one builds upon the first one, the third one builds upon the second one, and then each step along the way I will disclose my solution, and students can use my solution as the basis of the next homework assignment. So they don't even have to fix their own programs to continue to the next step. So the exam question was kind of like that. Okay, given this program, extend it to do blah, 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 blah. And it did not turn out quite the way I expected. So I just refrained from making those questions in the future. The most frequent complaint was there wasn't enough time to even make the program compile, let alone running correctly. So that's usually the biggest problem. And with a programming, with a practical question like that, I'm not going to assign partial credit, for this looks right to me. If the program doesn't run, there will be like 0 points. And to many people, that's a lot worse than having questions like these, where each one, may look a little nasty, but there's so many of them. Most people would get at least a few of these things, as opposed to the whole program not working completely and getting a 0 at the end. So that's why it's going to be a paper test. You cannot use a computer or any electronic device during the test. Okay. Are there any questions about that part? Yep.
Will we take the exam here, or
we are going to take the exam here, so you can put the keyboard away, so you have more desk space. Yep.
You bring a scan card or something?
Nope. You just have to write on the exam itself. I will give you the entire exam back, questions and your answers. Because I don't plan on using the same questions next semester anyway, so you can have it. And then the nice thing about the classroom like this is you can turn the monitor sideways if you don't want your neighbor to kind of peek at your answer. That becomes a kind of a makeshift privacy guard. All right, so let's move on to the next question. Number 4. Well, number 4 I really like. Number 4 looks like a whole bunch of gibberish, and it really should not be doing anything that's useful. Okay, so we'll take a look at this one and figure out what it's going to do. All right. Now with this one, it does matter whether we are dealing with 32-bit integers or not, but when you look at the values that we are dealing with, which is 65 and 72, okay, these values do not need even 16 bits to represent, okay? So you can basically just kind of imagine if I use 32 bits, there will just be a whole bunch of zeros or a whole bunch of ones. And as a result, you don't have to write out all the zeros and all the ones. Okay? All right, so let's go ahead and take a look at this one here. And the result of this operation is a little bit surprising. Okay, I'm just going to copy and paste it so that we can refer to it here. All right, okay. So this one I have to number the operations. The first operation is x exclusive or equal to y, which is the same as x equals to x exclusive or y. Okay, so we have to evaluate this thing first, and then we'll store the value back into x. All right. We already know what x is from the previous exercise. Okay, x is 45, and 45 is 101101, I think, if I remember correctly. And we'll give it some zeros, leading zeros, because we are dealing with bitwise not, after all. And if you feel like, you really want to make sure that this is exactly the same way, you can actually give it all the zeros that you need. But I'll do it in bunch, in like groups of 8, so it's easier to count. So now we do have 32 zeros, 32 digits, and we do a bitwise exclusive OR with the other one, which is y. Y is 72, and we have already figured out what that looks like in binary as well. And that should be 10010. Yep. No, up by 1. There we go. Okay. Because 72 is 64 plus 8, that's 64 plus 8. Okay, so we're dealing with a bitwise exclusive OR. And you have to look up the exclusive OR table, which you can bring with you to the test. Okay, so all of the notes that I have written so far, you can bring it along with you. If you find a really good reference text for C++ programming, bring it along. Okay, the only thing I have to warn you is the more stuff you bring along with you, the harder it is to find something, unless you have a really good way to index everything and it's easy to find stuff that you need. Okay, 0 exclusive or 0, according to the definition of exclusive OR, is 0. So we just end up with a whole bunch of zeros here, another bunch of zeros here, another bunch of zeros here, another 0 here. The only time you have a 1 with exclusive OR is there's only 1 and only 1 from both numbers. So this is going to be a 1, 1, this is going to be a 0, this is going to be a 0 because both are 1s. This is going to be a 1, 0, 1, and in base 2. Okay? That's the first step. And basically, after the first step, x is becoming this particular value. So we'll just make a note of this. The second step looks kind of the same thing as the first step, except the operation goes kind of backwards. Okay, so we'll go ahead and perform this operation backwards. Now the most important part is when we perform the second step, it is using the x that is already changed by the first step. In other words, the first expression, which is already evaluated at this point, has already changed the value of x. So that by the time we evaluate the second expression, it's using the changed value of x, not the initial value of x. So that is the part that you really have to remember, because most people would get caught by this one. Okay. All right. Exclusive OR is actually commutative. It doesn't matter which one goes first. But I will make y go first. Y has not changed at this point. So y is really just the same as before, which is this number, but x has already changed. And the new value of x is this particular value here, and then we perform the exclusive OR. And now you can see why all the extra zeros are not really going to be very helpful, because the result is not going to change much. But it doesn't really use up a lot of time either, so if you want to be sure that you have everything done correctly, you might want to just write it out. Okay? So this is the result of the middle expression in the comma separated expression itself. In other words, after this step, we have x being this value, and then we have y being this value here. Are there any questions? But that's not what we are returning to change x here, because we have a third expression which has no assignment components to it. It really is just calculating the exclusive OR between x and y, but it's not changing x or y by itself. It is going to change it later on when we perform the actual assignment operation. Okay, so we'll go ahead and perform that step. So we know what x is. Okay, x is still here. So this is our current x, and then we also know what y is, because this is the new value of y. So we just copy and paste it here. And then we perform the operation, and that becomes a bunch of zeros, 0, 1, 0, 0, 1, 0, 0, 0 in base 2. Is that okay? This is the result of the last expression of the comma separated expression. What is the significance of the last expression of a comma separated expression?
That's what the whole expression is.
That's the value of the entire comma separated expression. Well, so that's what we're going to store back into x, because this entire comma separated expression is the right hand side of an assignment operation. So we're going to use this value and update x. So this is the last update of x. X actually got updated twice when we evaluate this expression. Do you notice anything about x and y? They're exchanged. So that's the answer of this particular question. So when you write out x and y, you can just write out the base 10 number, or if you prefer, you can write out the binary number. Now, if you write a binary number, please use the parentheses 2 to indicate, or subscript 2 to indicate this is a binary number and not a decimal number. I just want to be sure. But if you write out the base 10 number, x is going to get the value of y, which is 72, and y is getting the value of x, which is 45. Are there any questions about number 4?
With the value of the expression would be the last thing we calculated.
Say again?
But the value of the expression would be the last thing we calculated.
The value of the
The expression.
comma separated expression is the last expression. It's the value of the very last expression. Right. Any questions about number 4? No questions? So we're going to move on to number 5. Number 5 looks like this, okay? Something that is vaguely familiar. And it's just asking, what is the value of x after, this assignment statement here, right before the return. And we have done something like this already today. So what you want to do is to basically, try to figure out this thing the same way. We have a local variable x which has a value of 46. 46 plus 2 is 48. So this argument is 48. This argument is 44. Out of 48 and 44, 48 is the maximum. Now you do have to check, the meaning of the function is correct. Okay, in other words, I may not be intentionally trying to trick you, but I used the wrong operator. You have to go with the operator, but not the name of the function. Okay, So this one, this entire thing evaluates to a value of 48. On the other side, we have 51 and 41 here. So out of 51 and 41, 51 is the maximum, which means this part is 51. 51 minus 4 is 47. So we have 48 and 47 over here. So the answer is actually 48. Is that okay? So you have to kind of figure out, in this case, you have to figure out the ordering of calling findMax and how we utilize the return value of findMax each time. Yep.
When we were returning in findMax function, are we returning x or y?
We are returning whichever one is the greater.
Okay.
That's basically the homework that was due today.
Because for homework I did x equals that ternary, I guess that's not.
But that won't work because x is a parameter, and a parameter will cease to exist when a function returns. So you don't want to, there's no point in changing the parameter itself. If you're using return x at the end, that's a different story. But changing x is not going to be useful unless you're using it as a return value. But this works as well. Okay, there's no need to store the maximum into something first because we can just calculate which one is the maximum and return it right away. Okay. So this one has the answer of 48. And this is the last one, which I think is going to be a little bit fun, because this is the kind of question that has partial credit. In other words, I ask what is the value of x after each assignment statement in main. If you get like 2 out of the 4 right, you get 50%. If you get 1 out of 4 right, you get 25%. If you get 3 out of 4 right, you get 75%. If you get 4 out of 4 right, you get 100%. So these are the things where there's partial credit. Yep.
So how many problems are there?
Probably going to be a little bit more than this, with more focus on question number 5 and question number 6. All right, so we want to take a look at this one here and figure out what is the actual value that we are that the function f is going to return, and it is recursive. Okay, so you can see that this is recursive because in function f itself, it has a potential of calling itself. Okay, it has a potential of calling f, and the difference is I keep calling f with x as the first argument, but the second argument is going to be fy plus 1. So the second argument will keep going up, each time I do the recursion. Okay. And the reason why I do the recursion is because x mod y is a non-zero, which means x is not divisible by y. Okay. So in other words, when you look at this entire expression here, it's basically saying if x is not a multiple of y, we'll go ahead and do the recursion here. Otherwise, we return y. Because x, in this case, x is divisible by y, and we return y. Okay? All right. So given a program like this, and you cannot use G++ or GDB to run the program, how are we going to figure out what this is going to do? Okay. So let's take a look at this one and try to figure it out. We'll work with the easier case first. And when you look at the question, there are a few ones that are easy and a few ones that are difficult. This one is easy. This one is easy. This one is a little bit harder. And this is the one that is the longest. Okay? But once you figure out the pattern, you may be able to figure this one out without even having to trace the entire program once you understand the meaning of the code. Okay? So we'll go ahead and take a look at the easy case first. So we're talking about question number 6 here, and we'll deal with f of 2 here. Okay? And since you cannot use GDB, I'm not going to use GDB to illustrate this either. Okay? All right. So f22, and remember, the parameters are allocated on a per invocation basis. So you have to kind of keep track of the invocations. In other words, there's a potential that the U-Haul truck is going to be sublet several times to different people, okay, at the same time. Okay, so assuming F22 is the first one, we are dealing with this guy here. Let's figure out what is going to be the return statement. The return statement is still going to be the return statement, but in this case, x is 2, y is 2. Okay. The first thing we have to do is to figure out, do we have to do any recursion in this case? Okay, because if you don't have to do any recursion, I don't even need to deal with this guy here. Okay, what is 2 mod 2? What is the remainder of 2 divided by 2? It's 0, okay? And if the condition expression has a value of 0, which value am I going to evaluate and return?
Right side.
The else, the false, or the last one, right? So it's going to be dealing with just y itself, okay? So y is also 2. So in this case, it's just going to return 2. Okay? So x basically is 2 in the first statement. Are we doing okay so far with the first one? Yep, go ahead.
How does it know which statement to go?
Which
Where
statement to go?
does it tell it, like, if it's 0, if x mod 0 is 0, then
Because it's a ternary operator, the behavior of a ternary operator is you have to evaluate this expression first. If this evaluates to a non-zero, then you evaluate and return this statement, this expression. If this evaluates to 0, then you evaluate and return this expression.
Okay.
That's the whole behavior of a ternary operator. Okay. All right. So I'm going to deal with the. Let's see. Well, why not? We'll just do it in a sequential way. So this time we're dealing with F32. Okay. X being 3, y being 2. So we have to evaluate the same kind of expression, 3 mod 2 in this case. And I'm going to finish the whole template first. But before we decide where to go next, we have to look at this expression and say, is that 0 or is that non-zero? What is the remainder of 3 divided by 2? Has a remainder of 1, and is 1 0? No, 1 is non-zero, which means this time we have to evaluate and return the one in the middle. Okay, so we have f of x. What is x again? X is 3. And what is y? Y is 2 at this point, but what is 2 plus 1? Because when we call f again, we're using my own value of y plus 1 to become the new parameter. Okay? My own y is 2, so when we call the next f, y is going to be 3. Okay, so let's pause here and make sure that everybody understands y in the next invocation of f, parameter y becomes 3. Because that's not the first renter of the U-Haul truck, that's the first subletter of the U-Haul truck. Are we doing okay so far with this part? Because this really is the crucial part. Okay. Now instead of writing 3, perhaps it is better for me to write this as actually 2 plus 1. Oops, 2 plus 1. Because this 2 is referring to this 2 here, which is the parameter to this invocation of f. Now, because I have to evaluate this expression and return its value, that means I have to call f again. So when you keep track of this one, then the next time we call f, we're going to have 3 for x and 3 for y as well. So we have to evaluate the return statement for the second invocation of f first, okay? And becomes 3 mod 3, question mark, something, and something here. What is the remainder of 3 divided by 3? 0. So that means we have to evaluate and return the else or the else or the false value. The false value is just y itself. Okay, let me move this one apart. It's just y. What is y in this case? In this invocation, y is 3. So it is 3 here. So this will return 3, and that 3 is going to be returned here. So eventually, this statement basically becomes this, because this entire invocation of f becomes a value of 3. And because we are returning this 3 here, this entire invocation also just becomes 3, and that becomes the value of x. Are we doing okay so far with how to keep track of a recursive function like this one? Yep.
So in this particular one, the value of x doesn't change. So, like, what would be the point of, if you already know that, what would be the point of tracing it, like, on the test, for instance? Like, because don't you, since x, because only y is increasing by
Yes.
1,
Yes.
x isn't changing, so how would x change, like, in the answer from the original, like, ordered pair?
Well, I'll show you.
Okay.
Yep. In fact, the next example is going to illustrate it.
Okay.
Yep. So is it okay, is everybody okay with this particular call to f?
So in the exam, do you want to write all this stuff down?
Oh, no. No. I just want you to write down, the value of x. Like, the first one is 2, the second is 3, and then the third one is what we're going to figure out next. Okay? Because I don't want to grade partial answers. If you show me a trace and it's partially right, what am I going to do with it, right? So that's why I'm not going to show. I will not ask you to show the steps unless it's explicit. You don't have to show the steps. Yep.
Thank you.
Mm-hmm. All right. So the next one is F4(2). Okay. And in fact, this time I'm going to do the whole thing here. This is what we want to evaluate. So we're going to call F. So the first time we get to F, we're going to say, okay, this is 4 because x has a value of 4, and this is 2 because y has a value of 2. Those two are parameters. And we know this is a ternary operator, which means we have to first evaluate the first expression and see whether it is 0 or not. 4 divided by 2 has a remainder of 0, right? And the value of 0 in the first expression means the else or the false value is what we want to evaluate and return. And this is really just y. If you look at the definition of the subroutine, that is just y, and y is 2, we're done. So basically, this becomes y equals 2, so x equals 2. So that's the answer to the third part of this question. So is that kind of answering your question?
Yeah, it does.
Yep. Okay, so we have one more to go, which is the fourth case. It's just a little bit longer, but it is kind of important to understand how it works. So now we're dealing with the last one, which is f of 5(2), okay? And the first one is using 5 mod 2, and 5 mod 2 has 5 divided by 2 has a remainder of 1, okay? So that means we have to use the then or the true value. And this expression is another invocation of f. We are only passing x along to the next invocation, so 5 is what we're going to pass here. But y is incremented every single time when we pass it along to the next invocation. Because to me, y is 2, I'm going to add 1 to it and use 3 to pass along to the next invocation. So I'm only writing this as 2 plus 1 to explain why it is 3, because it is my y plus 1. Okay? Okay, if that is the case, we're going to deal with the next invocation. So in the next invocation, it really is, the bottom line is it is F53. Okay? So when you go into the next invocation, you have to evaluate the same expression, the same ternary operator. Okay, so we'll go ahead and specify the entire format here. But to the second invocation of f, x is 5, that does not change. But y is now 3. What is the remainder of 5 divided by 3? 2, and 2 is non-zero. And because 2 is non-zero, we have no choice but to use the true or the then value again. So we have to evaluate 5, f of 5, comma, 3 plus 1 this time, which is 4. So that will become the next invocation of f, which is using 5 as x and 4 as y. And then we have to evaluate the return statement of the third invocation of f in this case. But first we have to evaluate the expression 5 mod 4 in this case, because y has a value of 4 in this case. And 5 divided by 4 has a remainder of 1, and 1 is non-zero, so that means we have to do it one more time. F of 5, 4 plus 1 this time, and this time we have F 5, and then we reevaluate the ternary operator, the return statement. But this time it is 5 mod 5. 5 mod 5 clearly has an answer of 0 because anything divided by itself has no remainder. So that means we are going to stop the recursion and we'll just go ahead and return y instead. But in this particular invocation, y has a value of 5 and we're just going to return 5. When that is returned, we go back to the previous invocation, which is this one here, and say, oh, you know what? We know what this is going to resolve. What this is going to resolve to. It's just going to resolve to a value of 5, and that becomes the return value of that invocation. And because we are executing this, we now go back to the previous return statement and say, oh, now we also know what this is going to resolve to, which is also just 5. And then that will also return to this one here, because the invocation of f is really just a value of 5 here. So each step along the way, we are just substituting the function call with the return value of that particular invocation. When we execute this return statement, we get all the way back to the original one, which means the entire f52 is just a value of 5. So x is updated to a value of 5 in this case. Yep.
So what's the meaning of this program?
Okay, what do you think?
Well, it's say like try to find the number that the x can divide to.
That's right. Okay. What do you think is going to be F92? 3. It's going to be 3 because 9 divided by 2 has a remainder of 1, and then do one recursion, then it'll become F93, but 3 is a multiple, 9 is a multiple of 3, so that one will actually return a 3, which in return will be returned by the first invocation, so that's basically just 3. In other words, this is the potential factor that we are testing, and this is the multiple that we are dealing with. It's basically testing, it's trying to find the first factor of x. That's what the program is doing. Yep.
So we said instead of like when we do the return statement, we want x and then y minus 1. We could go backwards, right?
Say that again?
So like instead of going up and like when we do the recursive statement, like we do x and then y gets plus 1, we could go backwards, like if we change it.
I'm not quite following. We are not really changing the value of y as a parameter. We are just calculating the sum of y and 1, and that becomes the value of the next, the parameter y of the next invocation.
But we could go backwards, right?
Go backwards?
So like it was x and then y minus 1?
That won't work because if we start with 2, which is the first prime number, and you go backwards, it becomes 1, and everybody is divisible by 1, so it will basically just return 1 in every single case, except for multiples of 2. You can test it. I mean, you can actually enter this entire program and change this to a -1, and then see what's going to happen with these guys. This will return a value of 2, this will return a value of 2, this will return a value of 1, and this will also return a value of 1 if you change this +1 to a -1. But that's a good test. I mean, that really is a good test to see if you can figure out what this is going to do. Are there any questions about this one? This is probably the toughest question of all the other questions, because you have to understand how functions actually operate. When you study for the exam, when you deal with something like this, or the factorial, function, or the Fibonacci, function, what you want to do is to go through GDB when you're studying, okay? And you find a way to track the recursion, okay? This is the way that I do it. doesn't mean that you have to do it this way. Okay, there are possibly different ways to keep track of recursion, and this is just one way to do it. Are there any questions? No questions? All right, so once again, the test is next Wednesday, not Thursday. And the time is same as the lecture time. It's going to go from 9 o'clock to 10:20. Okay, so we have 80 minutes for the test. Show up on time, okay, so that you have the entire period for the test itself. Bring a pencil, bring your own writing instruments, okay, so make sure that you have your pencil, your eraser, and stuff like that. I will bring some calculators along. I don't think you guys will need a calculator, but I will have some on hand just in case somebody wants to have one. And for the most part, I cannot answer any questions other than the clarification of the questions. So if you don't understand what the question itself is asking, I can try to clarify that. But if there's an operator, in the test that is clearly in the scope of everything that we have talked about so far, I cannot tell you what the operator is at the time of the test. All right. So that's it for today. You do not have any new homework assignments. This is it. So if you want to study for the test, using the lab period, feel free to do so, and I will be here to answer any questions. And I forgot to take roll again.